Can everyone hear me? Okay, cool. So I'm doing a talk today on sort of large management of data flow and empathic software engineering. Can I get a vibe for the room? How many of you are students? Oh, okay, right, a ton of students, awesome, right. And how many of you are games industry professionals? Okay, cool, quite a few. How many of you are like grizzled professionals, like 3-4+ years of development experience? Yeah, okay. All right. Okay, well this is good. So, hi, my name is Thomas. I'm a game developer. I work with Creative Assembly. That's me. I've been there for about 5 years, and I've been a head of engineering, the build engineering team, for about 3 years. I won't ramble on about myself too much, but I do want to talk about my job. Build engineering is not really one of the most famous roles in the games industry. It's sort of a very niche role. Not a lot of people have heard of it. Unless you've worked within your industry, you tend to know what your engineer does. And even then, a lot of smaller studios will not have a build engineer. So build engineering is all about sort of managing a lot of the software on your team. And managing the sort of risk that your developers go through. They sort of look after your builds and make sure that you can always work. They make sure you can work efficiently. I like to think of them as the oil in the machine. They're sort of like, they're the thing that keeps everything running smoothly and efficiently. So my two primary titles were Halo Wars 2 and Alien Isolation. They were two big projects of love for me. I've done some consulting work with Creative Assembly on the Total War titles, which some of you may have heard of. But these, I predominantly work on the console team. So what are we going to do? Hopefully today we're going to learn something. We're going to go over a whole bunch of things to do with version control. That's Perforce, SVN, Git, things like that. We're going to cover some risk management methodologies, how to avoid lost time, lost money, and things like that on your project. That's all to do with managing your data flow. And I'll talk a little bit at the end about how to become a little bit of a better developer. We'll cover some empathic software development practices and things like that. We're going to be covering a large problem space. So I selected one particular problem that we had on Halo Wars 2, so we'll cover that problem, and then I'll show you how I did it during the development of Halo Wars 2. I'll then show you maybe how I should have done it on the development of Halo Wars 2. We'll take a look at some alternatives for the smaller studios. I'm guessing nobody here is sort of, right, there are very few people working on like large teams of sort of 200, 300, 400 people plus. Okay, that's what I thought. So we'll have a look forwards. We'll take a look at sort of the alternatives for the smaller studios and how you can sort of set up your Perforce. So basically, to give a bit of context, there's going to be like a lot of jargon and things like that in here. I'll try and keep it as base level as possible and as understandable as possible. A lot of the students may not have worked in depth with too much version control. But to explain a little bit better, version control is all about your work environment. It's a record keeper, a context sort of. It's a reconciliation tool, right? So any change that you make within your game, it tracks those changes all the way back to the history from you and every other developer on your team. It's a collaborative work environment. It creates spaces for you and your teammates to work together. We use Perforce at Creative. For the most part, in large studios, Perforce tends to be the default sort of industry standard. But there are others such as SVN and Git. Unity has its own one built in, things like that. We'll cover a lot to do with streams. So whenever I refer to a stream, it's sort of, I guess I want people to think of things like code lines and branches. That's not a new technology. Most version control software has something like that. When I refer to streams, and there is like some technical difference between streams and branches, for the most part you can regard them as functionally the same thing. So a lot of you might be familiar with something like this. You have a main line, right? Or maybe a dev 1, a dev 2. They might be named slightly differently. These are the areas that you check your work into. You might be familiar with mergers and integrations. But to just sort of like cover it, hopefully I'm not sort of teaching anyone to suck eggs here. Mergers and integrations are essentially the movement of data from one location into another. So we'll be talking a lot about mergers and integrations. And that is taking data, let's say from dev 1 into mainline, and then mainline into dev 2, and then propagating that data back from dev 2 into dev 1, right? There's a reason we can't go sideways here. It's to do with sort of like healthy data flow rather than rather than actual restrictions. But for the purposes of this, we'll sort of cover propagation of data through mainline. Interactions and integrations tend to take a lot of time. They tend to be very, very time intensive, and they often tend to require human interaction, which are two things to keep in mind throughout the course of the presentation. So let me give an example, right? Super quick example of people checking in and then integrating that data. So this is a great example by Laura Wingert in her book Practical Perforce, which is basically one of the only literary works on version control that there is. It's not the most exciting topic typically. So we have Frank. Frank is our developer. Frank is working in dev 1. So he's writing an instruction manual, and he writes into his instruction manual, you must bring your birth certificate when you register. It seems fairly simple, right? He checks into the dev 1, and then dev 1 integrates into mainline and down into dev 2. That's the propagation of Frank's changes, integrating into the rest of the work environment. So now all the developers in main and dev 2 have access to Frank's changes. Joe's sitting in dev 2, and he sees Frank's changes, and he's like, oh, yeah, no, you're right, you do need a birth certificate when you register. However, you don't actually need the original one. Let's say you can have a photocopy of the original. So he makes the changes. He checks in, alters Frank's work, and checks it into dev 2. And he says, you may bring a photocopy instead of the original. So that data gets integrated at the same time, however, unbeknownst to Joe, Frank is making changes back in dev 1. And he makes changes saying, you don't actually need your birth certificate. What you need is your parent or guardian. So he makes that change and checks it in, back into dev 1. And then these two sets of data meet, Joe's changes and Frank's changes. And we end up with this. You must bring your parent or guardian when you register. You may bring a photocopy instead of the original. So this is quite cute. It's an easy example to see where two independent developers who have done nothing wrong have ended up with an error in their work, right? And this is just a very simple text-based instruction manual. Now, the important thing is to take this example and extrapolate it out. Imagine you're in a team with 10 developers, right? And you're not writing instruction manuals. You're writing C++, C#, even just XML, dialog lines, something like that. And then you have these sorts of errors that you have to keep up with when you merge data from one area into another area. And suddenly those C++ errors, like merging C++, much like Frank and Joe have done here with their text, it becomes possibly problematic. And then extrapolate that out even further to 180 developers, 200 developers, 300 developers. And think about the impacts that something like this might have when you have, let's say on Halo Wars 2, there was about 750 to 800 lines of code. There was tens of millions of lines of XML. And maybe this starts to you can see how it starts to become a problem. The propagation of data from one area into another and dealing with the integrations and the resolves that happen. So I'll give an overview of the problem. It's roughly divided into 3 layers. Layer 1 is risk management. So as we saw in our example, when we merge 2 sets of data, 2 developers can do something entirely right, and then you merge them together and you have a broken set of data. Right? That data is not necessarily just data, it's changes, right? That's sort of representative of changes. So layer 1 is about risk management. Risk management is all about making sure your developers can always work. Whenever your developer can't work, you're losing time and you're losing money. Layer 2 is all about how you mitigate that risk and dividing your developers into relevant groups. So, this might not be hugely relevant on smaller teams, but it's definitely still a thing that should happen. Whether you're splitting between dev 1 and dev 2, or whether you're splitting between art and code and design and things like that. So the real challenge is how you go about doing this and what the criteria is. And the third layer is about that flow of data, the integrations from one area into another, and how you manage those integrations. So let's take a slightly deeper look. Risk management. This is all about lost time. Time equals money in this industry, and in every industry. We want to avoid check-ins that break the build, and if something does break the build, then we want to minimize the amount of time that that build is broken, and the number of developers that it's broken for. So when I say the build, a lot of you might think of maybe like the build is your game, but it's not necessarily your game. The build can be anything that you require in your work environment to work. So if you have your engine developer or your gameplay coder, and your solution doesn't compile, that's a broken build. If you have your level designer and your tools don't compile, or your tools are broken, that's a broken build. If your game doesn't work, that's a broken build. So I'll give a practical example of this. Let's take 1 day every 3 months, your developers are blocked, right? A cumulative total of 1 day, right? And that's not very difficult to achieve, right? So 1 day is maybe 20 minutes here, 30 minutes there, half an hour, doesn't matter. One day over the course of 3 months is very, very easy to become blocked for that amount of time. You extrapolate that out for a 3-year project. So 1 day every 3 months over a 3-year project, and you have 180 developers. That was the amount of developers we had on Halo Wars 2. That is roughly equivalent to 2,160 days of lost man time, or about 6 years. I don't know if any of you can really imagine what 6 years of work might look like on your team, on your game, if suddenly you were to inject an extra 6 years of man hours into your game, what kind of difference that might make? It's probably pretty big. If I wanted to put a price cost with it, let's take a rough salary of 40,000 euros. That's about €250,000 over the course of 3 years. And this is why we don't all work in one area. Because when you have 180 developers working in a singular work environment, like an isolated mainline, somebody checks in and breaks the build, you have all 180 of your developers blocked. So we divide our developers into subgroups. So how do we actually do that? That's the primary problem we have here. Let's say you have 180 developers. You're like, could you divide by feature, by pod? You can divide by discipline, art, code, etc. You can divide by hair color, you can divide by shirt size, whatever. Here I've taken that same diagram that we had before. We split it into code and art. This is a fairly simple one, but this is still not really very much divided up. You have 2 primary development lines, but that means you probably got an average of like 90 people on each if you're working on a 180-man team. So maybe you want to split your code up a little bit more. You go network code, engine code, UI code, AI code. And that seems maybe a bit more reasonable. We have 4 independent areas of code. You have maybe 20 to 25 developers in each one. Somebody checks in and breaks one of their streams, that's only 20 people blocked. And I say only, that's still a ton, but it's certainly a lot less than 90. So we want to do the same thing with art, though. Let's divide art into environment art, or character art, or concept art. But how far do we go? Where do we stop? We can divide further and further and further and further and further. Audio, tech art, tools, VFX, design, level design. There are millions, hundreds and thousands of sub-niches within your development team. The wider and wider and wider it gets. So this gets a little absurd. I remember every single one of these new streams that we've just created in order to help our developers become unblocked. Well, all of those require an integration into the main line. And then all of those require an integration back out of the main line. Maybe you can see why this might become a problem. And that brings us to the flow of data. So the flow data is the natural and third part of that problem. When you try to migrate data between these crazy work areas, it takes a lot of time. So you take one of your code streams, you integrate it into mainline, and then you integrate that data back into your art stream. But then you have like 5 different art streams, so you've got to integrate that data 5 different times, right? Every single time that gets integrated, it can fail. The integrations can fail based on conflicts, based on other people working on other things, similar work, dependencies, things like that. What you start to find is when you have so many integrations to do, you start to form a priority system. You take your priority system and you form a queue out of it, and that queue can cause blockages. As items slot into that queue here and here, you tend to form a priority system. And then as integrations fail, or they take more time, your queue becomes more backed up and backed up. And remember, every single one of these integrations has to be tested. So whenever you integrate data from one place into another place, you have to test that integration. Otherwise, you could be integrating the blockages that you want to avoid by separating your developers out anyway, and it defeats the whole purpose of the whole system. So this is kind of like our crazy diagram of this, right? Every single one of these would require an integration to and from mainline, a test every single time one of those integrations is done in order to avoid anyone getting blocked, and it gets a bit crazy. So on the top of it getting a bit crazy, let's talk about Halo Wars 2. So this is the game I've just finished developing. We've just finished shipping the last of the patches. So we'll talk about how I tackled these problems, how my team did, where we fell down, and what we learned out of it. So, risk management. We wanted to minimize risk, as every team does. I'll take a second to talk about the nature of stable versus unstable development. So a lot of you might be used to working on smaller teams. Maybe you're used to working in pre-established engines, Unity, Unreal, things like that. We were in unstable development. And what I mean by unstable development is when you have, I'm going to roughly divide it into 3 distinct areas: your game, your engine, and your tools. If you're working in something like Unity, you probably have a very stable development, right? You always know Unity is going to work, right? You're always going to be able to just load up the latest version of Unity, and 99.9% of the time, Unity works. I hope. Unity itself will work, right? Your code might not work. But for the most part, it's fairly good at working. The tools, Unity tools will always generally work. However, as you progress up and upwards into larger and larger teams, you will find that the tools are more likely to be developed in-house. The same with the engine, which means you add extra risk to things. And then you have the game itself, and almost everyone will be working on their game, unless you're Unreal, in which case you're just working on a set of tools. So whenever you check in and you break your engine, you cease game development. Nobody can work on your game if you've broken your engine. They can't load the game. Whenever you break the tools, a lot of people can't work on the game. Whenever you break the engine, you also often break the tools, which makes tool developers very unhappy. And whenever you break the game, you break the game. So, what this essentially means is that as you add each of these sort of primary categories, you become more and more unstable in your development process. So, we were working on Halo Wars 2. We were developing an engine, a tool set, and a game all at once. And that became like a really big problem, because we were developing these not in a linear fashion. We weren't going, right, okay, let's build the engine, done, right, okay, let's build the tools, right, okay, now the tools are done, the developers can work on the game. We developed all 3 of these in conjunction with each other, which created a lot of problems. So we were working on our game, our tools, and the engine all at once, and that is a ton of risk. So, as such, we wanted to minimize the amount of risk as possible, as much as possible. And that takes us to how we divided our developers. So, we split our people into groups. We split them by pod, which is sort of production-led teams. We split them by feature, the kind of features that they are developing. So you'd have like your gameplay, your let's say your movement coders working with your modelers, the people designing the units and things like that. They would all work in a feature to create units together. And we've split them by discipline. We split them by everything. We split them by way too much. This was a bit crazy, right? This is nothing. So this is where we really, really went wrong. And I'll give you guys a second to suck this up. We have our crazy graphic here about, too many integrations, too many streams, too many subdivisions of our team. And this is what it was like on Halo Wars 2. It's still going. Yes, we shipped this game. Somehow. So yeah, that's what we worked with. Okay, no, okay, right. Maybe most of this was my fault. But I'll give you guys some backstory there. When we worked on Vikings, which was an earlier curve assembly console team title, everyone worked in one stream. There were like 120, 130 people. We all worked in one area. And we all came away from that going, God, never again. Just never, ever, ever again, right? We all worked in one area. Whenever one person just checked in one broken XML or one broken CPV file that broke the whole build for 130 developers all at once, it was terrible. And then we worked on alien isolation, and I split that down. I was just like, okay, that's fine, that's cool. We'll take art and design, and we'll put them in the content stream. And then we'll split the coders up into the code stream, and then we'll have a mainline as an integration point. And that was better, but all the coders sat in that one stream were just like, oh my God, just whenever anyone checks in and breaks the build, I just can't work. It's just so infuriating. And then Perforce introduced this stream technology, which was a very lightweight method of creating these sub-branches where your developers can work, right? And I just went crazy. I was like, all right, cool, we got so much lightweight streams, we just like have, you have a stream and you have a stream, you know, that old Oprah gif, right? And I went a little nuts. So what I didn't do was I didn't appreciate the logistical cost associated with these areas. It didn't occur to me back when I was working on Alien that the integration between the code and art stream took like maybe half a day, right? And so when I created all of these lightweight streams, I created a ridiculous amount of work. Truly ridiculous amount of work. We had hundreds and hundreds of streams. It got so bad that my team couldn't keep up with the integrations. I had a team of 3, it wasn't just me anymore. And we ended up getting QA doing our integrations. And every single one of those integrations required testing because, as I said at the beginning, if you don't test your integrations, then it defeats the whole point of doing it to begin with, of splitting up your developers. So the QA, the poor QA guys were sat there just like trying to, integrate via Perforce and test the game and compile everything, and if anything was broken, it would have to cancel the whole integration, roll it all back. Any resolves would have to involve coders running left and right and center to sort of go and help out the QA to resolve their code and their data. And that queue that we talked about earlier, that prioritization queue just became unmanageable. It became completely ridiculous. It stopped being a prioritization queue where we were like, okay, what needs to happen where? Like, let's get through that. It became like a triage, right? A field hospital of what is currently the biggest emergency that we need to deal with right now. Oh my God, right, we need to ship our E3 demos. All right, everyone else takes second place to the E3 demo. That happens. We need to ship something over to Phil Spencer, because Phil Spencer occasionally likes to view games. And we're like, okay, everything else stops, right? Just the Phil Spencer integrations, they happen. Okay. And it creates this kind of, this triage that creates blockages, not because things are broken, but because there are dependencies on other people's work. So we came away with a few lessons from that. Streams? Yeah, they're good. Appreciate the logistics, though. Appreciate the time it takes to manage any individual work area that you decide to create. More focus on risk groups. So I highlighted earlier how we did it on alien isolation. We split down. We went into code and content. And for the most part, those risk groups, they actually, we should have learned from that first. We didn't need to subdivide art even more. Okay, let's take an example. If an environment artist, and I'm picking on the environment artist here, if an environment artist checks in, generally the worst thing that happens is that a rock will turn pink and they break something, right? So, there is a risk associated with an environment artist checking in, right? An environment artist checks in and they break the build, or they break something, a rock is going to turn pink. Something is going to turn into a checkerboard texture. I don't want to be picking on any environment artists out there. For the most part, they are in a low risk group. They can check in and put things out of memory and things like that, but for the most part, it's a low risk group. Your engine developers, however, they check in, they can screw everyone. They can stop the tools guys from working, they can stop any game developer from working, they can stop all the rendering software, everything. So they are a high-risk group. And what we did between Alien Isolation and Halo Wars 2 was we decided we didn't focus on our risk groups. We split down our developers. Instead of splitting them down by, okay, you're high risk, okay, you need your own stream, right? You're medium risk, maybe you can have your own stream during like large feature development and things like that. But environment artists and character artists and concept artists, oh my God, concept artists never break anything. Like, I don't even know what I was thinking. Like, yeah, guys, you make your pictures. They are awesome, but like, they're just so unlikely to break anything. I kind of wish everyone could be like them. So, but I gave them all their own stream anyway. I'm like, yeah, you can have your own stream, you can have your own stream, you can have your own stream. They're all super lightweight, they're great. And I didn't need to do that. What I needed to do was focus on who created the risk, and if you didn't create risk, then you could all just work in the same area. Like, I could have had level designers, balance designers, the sort of the UI guys, the concept artists, the character artists, environment artists. I could have put them all in the same location. Because for the most part, as they all work together, their risk is so low that nobody is going to become blocked, and you don't lose that lost time. You don't lose that time, and then you don't lose the money associated with that time. And then I should have divided up the coders into associated risk groups. Not just coders, I'm picking on them. Tools developers and tech artists and things like that. People have the ability to impact a large audience when they break something. So, and this is a big point. I've talked a bit about a broken build, and a broken build can block people from working. But a blocked queue can as well. So, no developer works in isolation. They need other developers' work in order to continue working. So, I'm going to pick on the environment artists again, right? Environment artists want to keep working on their rocks and their terrain and things like that. They often need like the latest rendering technology if you're innovating rendering technology, right? If you're building your own engine, your environment artists will want to see how their terrain and how their models look in the game. So there is a dependency there, even between a low-risk group and a high-risk group. They have dependencies on work, and when you have a blocked queue, it stops those dependencies from getting that data from migrating from one end to the other end. So that's kind of what I didn't appreciate. I focused too much on stopping broken builds and didn't focus enough on the speed of feature propagation. I also learned a lot about who can manage their own integrations. You can have super lightweight streams. You can have hundreds of work environments, right? But people can oftentimes actually just be left to be responsible for their own areas. So the coders, for the most part, if I gave them a task stream or a development stream that they could work in when it was just like 2 or 3 of them or just one of them, they actually manage their own integrations really well. The same with the tech artists that I worked with and tech animators, right? They knew their Python scripts and their Maya scripts and their Mac scripts, right? They knew them well enough to migrate that data themselves as long as they knew the process. So I had to, you know, like it was a small amount of teaching to sort of a medium-sized audience. I was like, hey, this is how you migrate your data. This is how, you know, you do a perforce integration. This is how to do it safely. And for the most part, like it meant the QA or the build team or anyone else wasn't sat there just like trying to migrate their data and struggling with the resolves and the integration errors and things like that. Like they could do it a lot more effectively themselves. Start large and slim down. This is a principle that we applied on Halo Wars 2, and for the most part was correct. I think as you saw in that GIF, we maybe started a little bit too large, but this is essentially the working with the principle that as you work on your game will get more and more stable as you progress through time. So if it doesn't, you have bigger problems than the number of streams you have. But so you start out with unstable streams, right? People doing prototyping work, people doing random changes that can just break everyone, right? And as you progress onwards, you get into more and more stable streams, and as your development gets more and more stable, you can afford to put more and more people into the same work environment, to the same stream or the same branch, right? So again, it comes back to risk groups, right? As your risk groups get less and less risky, you can put more of them together. You can migrate that data. You have to be able to appreciate the migration of data in between those risk groups, in between those streams, but for the most part, you can slim down as you progress through your development cycle. Oh yeah, final lesson. Don't be this guy. So, I wanted to focus a little bit on something I learned during that. and it was focusing on what people want. For the most part, people wanted a stable work environment, and that was key, and I tried to create that. So by subdividing down our developers, we created more and more stable work environments. But they also wanted fast propagation of features. That is, getting other developers' work, being able to see the latest game, the latest design, the latest levels, the latest rendering technology, the latest lighting. And they also wanted an ease of collaboration. So you have this kind of seesaw, right? As you increase safety, as you decrease safety, you increase speed. That is the nature of everyone working in a single main line. Feature propagation is instantaneous, right? Somebody checks in and you can just get latest and you have that feature. But if somebody checks in and you get latest and it's broken, you're broken. So the speed of feature propagation is directly inversely proportional to the rate of to the percentage of safety, I guess, right? Something like that. So you split up your developers into hundreds and hundreds of streams. Everybody's super safe, right? Nobody's build gets broken. But that speed of feature propagation is really, really low. So there's a balance in there somewhere. Actually, I'll go back to this. There's a balance in there somewhere between the speed of feature propagation and the safety in which safety of the environment in which your developers work. If I were to take like a sort of rough bit of math here, let's say you have 180 developers. They check in 10 times a day, and on average, they have a 0.1% chance of breaking the build. That means that, oh God, I should never do live maths. Okay, right, so let's say that every developer has a 1% chance of breaking the build in a day, 0.1% chance per check-in. And you have 180 developers in one stream, that is an 83.6% chance of the build being broken on any given day, I think. Are there any mathematicians out there who can correct me? Okay. If there are, don't correct me. So there is obviously a balance to be struck. And this is kind of where I wanted to like segue a little bit into what I like to call empathic software development. Having sort of talked about discovering what people want, what they actually want out of their streams, out of their work environments, it kind of gave me the impetus to talk a little bit about empathic software development. And this is sort of known by, like, I guess the principle is known by like a lot of different names. You know, it's other-centric, it's client-centric development, client-centric problem-solving, solution development, things like that. I'm just going to go with empathic software development. So there's a great quote, which I'll read. Fixing problems means, first of all, understanding them. And since the whole purpose of the things we do is to fix problems in the outside world, problems involving people, that means understanding people and the ways in which they will interact with your system. It's fundamental in every step to building a system. Essentially, engineering is all about cooperation, collaboration, and empathy for your colleagues and your customers. And that's really important. This is a quote by Jonathan Zunger, who, until very recently, worked for Google. And he drives home a very, very critical point here, which I hope to sort of kind of get out there a little bit more. And it's the nature that when you solve a problem, when you develop a solution, you're not doing it for yourself, right? There's a bit too much kind of, I guess it's too common amongst developers and software engineers that they will solve a problem because it's a problem to be solved and not focusing on the ease of their solution for other people. So on the build team, the problems we solve are very client-centric. And when I say client, they're not necessarily clients external to your building, things like that. My clients are my team, right? They're the developers that work on my games. So when I solve a problem, any solution I come up with has to be interactable in a favorable manner by the people I'm solving it for. So I'll tell a quick story. This stream system that I've been describing, that we had on Halo Wars 2, I didn't make the mistake of creating too many streams as the only mistake. One of the biggest mistakes I made was, in fact, creating an environment that was uncomfortable to work in. So to describe that, right, that GIF that you saw, it looks kind of complex. For the most part, it's fairly rudimentary and fairly easy to move your work environment from one stream into another stream. So we had people switching streams all the time. Like, you would finish work on one feature, and then your producer would say to you, right, okay, you need to move into the next stream. You need to move into this area. And then you need to work on your next feature for the next sprint, and then you need to work into the next one, and the next one, and the next one. People would be hopping their workspace around like every week. For me, that's easy. Right? I'm used to Perforce. I'm used to version control. I can create micro workspaces. I can migrate data. I can bounce my work back and forth and shell and revert and make sure that everything I have is up to date. It's easy for me. And so I created this solution to do all these streams in which, I guess, I imposed the ease in which I have in dealing with the system on everyone else. And that was a mistake. That was a really big mistake. Because the artists and the coders and the designers, they didn't want to do that. Breaking someone's flow of work is a really big deal, right? Flow, that kind of zen that you get into when you're really in the zone, disturbing that, even with like a small thing, is a really bad thing to do. And me as a developer, creating a solution, creating a problem that, creating a solution to a problem that of, safety and data migration and things like that, and not accommodating for the needs of the people that I'm developing that solution for was incorrect. So for the most part, designers and developers, they just didn't want to interact with Perforce. They didn't want to have to sit there and move streams. It was a pain for them. They didn't want to have to migrate their data or shelve their old data or have to like leave their changes behind, right? It was an uncomfortable work environment for them. And I imposed that work environment on them. So something to always consider whenever you're developing your solutions, if they're going to be client-facing, if they're going to be facing your team or your external clients, external customers, right? They need to be built for that person. You wouldn't, someone hires you to build a website, right? And you're like, cool, yeah, I'm going to build my website, done. You make your website, you send it off to the client, and they're like, I can't navigate this. This is so unintuitive. And you're like, yeah, but no, you just do this, right? You just and you try to teach them how to navigate your solution rather than building your solution to fit their needs, right? You just would never think of doing that. But it's a practice that's perhaps a little too common within software development in general, particularly amongst the younger developers. The younger developers are more inexperienced developers, and you tend to find that as people progress into lead roles, they tend to become more collaborative. They tend to become more empathic, more socially driven, right? A purpose of a lead in a software engineering team is to understand the problem that they're trying to solve better than their team, and then they direct that down to their team. Which I'll go on a side ramble here. That's why oftentimes when you meet a team of software engineers, the lead is often not the best software engineer amongst his team. Me and my team, I'm not anywhere near the best software developer on my team, right? I know that. The first guy I hired, my engineer, James Hyde, was so much better than me when he first started. Like, I was like, yeah, I'm an amazing build engineer. I'm automating all my stuff, right? And I'm like, okay, cool, I'm going to take a step into this lead role. I'm going to hire my first guy. And he was just like, no, I'm just like infinitely better than you. He was just automating, things within the first 6 months that it took me years to do, right? Now he just wants to automate everyone out of a job, and I have to like calm him down quite often. He gets super excited about it. But that's fine, right? That's his jam. As a lead, what my job now is more to like direct that focus of his, to take that crazy energy and enthusiasm for automating things and developing solutions and be like, right, we need to develop these for the people that we're developing them for. He made this crazy tool that tracks change lists throughout Perforce, so you don't have to interact with Perforce. And it was great. It was super simple, really easy to use, and as he worked on it more and more and more and more and more, it got more and more complex, and it just got to the point where it was actually just easier to use Perforce. So, we had to review his solution and scale it back and make sure that it was usable for the people that it was directed to, and that was production and things like that. And they don't want to have to interact with like really scary, like complex software. So who are you solving a problem for? Your client or your team? And very often they're the same thing. And remember, you can't fix the people. You should be focusing on their problems instead. If your solution to an artist or a designer coming up to you and being like, your tool just doesn't really work, it doesn't like this, if your solution to that is to try and educate them, then it's probably more likely a flaw with your software, a flaw with the solution that you've derived, than a problem with the person that's trying to use it. So we'll take a look forward into some alternatives and some things for the future. Try to remember there are no right answers. There are definitely wrong ones. But everything I've said here it's quite, like these are all experiences that I've had of working on large teams. A lot of you will be in smaller teams. A lot of you will be working in 5-man projects, 10-man projects, 20, right? Focusing on the things I've said, take the principles away, not the practical applications. Right? That is, do you need separate work environments? Is a particular member of your team or small group on your team very risky developers? Are they working on crazy features and things? Are they going to break the build every time they check in? Yeah? Okay. Maybe we just take a stream, put them in there, right? Your stream setup doesn't have to be 500 streams or 1,000 streams. It doesn't have to be everyone working in mainline, right? It should be a dynamic process based on what your team needs. So, like I said before, it all depends on the safety of your environment. If you're working in Unity, your tools and your engine probably work. But if you're not, then maybe you want to consider that. Maybe you want to consider tools developers being in their own location, engine developers being in a location. You're innovating your lighting or your rendering, put them in their own location. So automation, oftentimes when I talk about this stuff, people bring up automation. They're like, oh, can you just automate all the processes, the migration of that data? You can just put it all through a machine. Like, maybe. It's limited. As I said right at the very beginning, automation, integration of data often requires human interaction. And that's because a machine would look at that, you know, our Frank Joe example earlier, and would see nothing wrong with it. It would go, yeah, okay, look, you know, you've got one change here, these two changes don't interact, so slot them together, cool, done. And that would be wrong. So very often your integrations and your migration of data is very human-orientated. You can't integrate with automation, or at least it's difficult to integrate with automation, but you can test, and that's a really big deal. Testing and automation testing going forwards and in the future is going to be a large part of the industry. It's already something we're massively scaling up at Creative Assembly. It helps trim the time off those integrations, off those large data sets. If you leave your build overnight to test, like even in small development teams, you can generate your build, kick it off for automation, send it away for automated testing overnight, get some results back in the morning, and those results can be hugely helpful. So this is a massive topic of automation and its place in the games industry and the roles. So I'm not going to get into it a huge amount here, but if anyone's super eager about talking about, you know, how to automate people out of jobs and things, then come and talk to me afterwards. I'm like very enthusiastic about talking about this stuff. So in conclusion, we covered a problem. We covered risk management and assessing your risk groups, dividing your developers up, but don't go overboard. Migration of data and appreciating the logistics that it takes. We covered hopefully a little bit about how to be a better software developer. Who you're solving a problem for, be considerate, and fix the problem, not the people. Thank you all very much for listening. Any questions?